My name is Shri, and I'm here at USC. So, like many of the speakers in this session, my lab is also very interested in gathering data and analyzing, making sense of it, mostly from people and about people and the context in which they are. Today, I will sort of share some of the work we do in analyzing and gathering biobehavioral data from people. And I'll use a case study of an ongoing study that we were doing in a hospital. It's an IR plus study. So mainly here in behavioral machine intelligence, so our goal is to understand sort of human behavior, the human condition in general, and try to see if we can build technologies to support and enhance their experiences in their environments. And we know this is not a new topic. People across various fields have been interested in this, understanding human behavior, whether it's user modeling, customer care, to a lot of applications in health and well-being, which is one of the big sort of motivators for my lab, particularly mental health and other kinds of things in the workplace. So the question we ask, and a lot of this has been very human oriented in how we analyze, understand, and intervene. And the question which has been sort of popping here is like, what's the role of engineering? So in this particular domain, what we've been trying to do is to how we seek a window into this human condition. A lot of it is latent, like emotions, moods, and what next move people will make, and what decisions that they will take in a particular environment, depending on many of the things we've been talking about, right? Based on whether it's their thermal comfort or other aspects of lighting changes, etc. And how will it influence what we do, right? Whether it's a learning environment in schools or in a hospital where patients are trying to get better, people are serving them or trying to help them, etc. And we want to make this, which is it's been largely qualitative to quantitative and scale it up, which we heard again from other speakers. So the way sort of we define behavioral machine intelligence is to say, technologies support human or autonomous decision making. It doesn't need to necessarily be sort of, turning on some gizmo, but actually helping humans get a better understanding to make decisions and take some action in response using sort of evidence, sensor, data sciences, and AI technologies. A lot of different angles to it when we think about it. Some of it is people know what they're looking for. They know that we are looking for when a learner is more engaged than not, and if we know that and model and predict its constructs in a more efficient way, perhaps we can personalize learning, right? Others are more open, right? Like affect regulation is a very important topic in behavioral sciences and psychology and so on. And it's very hard to sort of just humans to understand how people are regulating affect and how it influences the actions that they take. Maybe these kinds of new data can help us get insights into these kinds of constructs and hopefully support diagnostics and personalized interventions and response to treatment, right? Actually, again, a lot of it is inspired by our interest in health. So in general, we believe that these multimodal biobehavioral signals and signals from the environment kind of provide a window into this human state and process. We heard from other speakers in this session how we can gather, for example, physiological data, right, from distance, using all technologies. Others are sort of more easily accessible, like audio, video data, and of course complemented by environmental measurements, right? With IoT, Bhaskar was talking a lot about it. So how we put all these together to make sense is like it's not an easy thing, particularly in quantifying this very dynamic human behavior, which is like a challenging problem. But if we do that, we can understand how people encode and decode information, because it's not just how we express ourselves and act, but how other people in the environment are reading us and making their moves, particularly in a complex environment, whether it's like a workplace and so on. So we call, like we've been doing this, like behavioral signal processing sort of tries to quantify expressed behavior and also human felt sense. A lot of it is based on people's perception and judgment of other people's behavior with the data that they have access to. Some of the intelligence or smart environments we're creating can go extra, can have augmented way of accessing things like heart rate and blood pressure, which just in an interpersonal circumstance we may not be able to have. So already we heard from many people, a lot of advances are happening, in sensing, the confluence of sensing, sort of machine learning, in various areas, whether it's audio, video processing, or visual activity processing, physiological signal processing, IoT technologies, like a lot of things are happening. Signal processing and machine learning at this processing stage is like our key enablers, but that's not enough. People, particularly, in this context of built environments, we can think about both instrument and environments, with arrays of sensors, right? Goes back to one of the first things that when I came to USC from Bell Labs also in 2000. We started constructing these smart rooms, right? Like put sensors everywhere, and so rooms can communicate, create immersive experiences of people who are not in the same space, type of an idea, and we can complement that with other things, about temperature, light, and air quality, etc., and sense the users in different sort of environments. But also we can now, with increasing wearables and so on, instrument the people also in these environments, which kind of takes you outside built environments, how we can have a seamless context. So that's been it. So this sort of intro part, sort of basically in the human-centered behavioral machine intelligence area, we are interested in computing data about people, their action and behavior, to support sort of meaningful analysis by collaborative sort of human and machine intelligence. That's kind of the approach we take. So what I'll do is now dive down into one ongoing project that is happening, supported by IARPA, where we are interested in tracking individuals in their natural environments. And we particularly chose a hospital environment, study clinicians. The idea is to see how individuals deal with various competing demands that the workplace provides them, in the broader context of the individuals themselves, their health and well-being, and how they can sort of both perform well and be well. So this is a mistake program that I kind of lead a bunch of partners. And so the idea is to bring together sort of multimodal sensing, sort of integrated continuous measurements of people, everything from physical activity. Our target population was clinicians, nurses, and clinical staff. Physiology, we use garment-based sensors, and we don't have the cool things from remote sensing yet. And social interaction, because it's very important. So we had created audio badges that record their day, their 12-hour shift worth of audio data, and digital activity on smartphones. In addition, we had environment sensing about usual sort of temperature, humidity type things, but also location sensors, the Bluetooth beacons, and other kinds of stuff. I'll just say more about it. And we had a cell phone acting as the portal that would kind of collect data about the people and the environment, so that we could actually sort of stream it as we're collecting. So this was 24/7 operation hospital, so people worked 12-hour shifts. Some of the sensors people had even outside, like the Fitbit charge. So we got some notion of their physiology and sleep and those kinds of data. And some surveys, EMAs, how people feel about their day, which is not necessarily convergent with what's really happening, but it's important. And then, we had a number of ideas and constructs that we were after about, like everything about their personality and their mood, stress, and performance, and so on. We tried to understand every individual before, after, and during, and so a lot of data that we've been collecting. And as I said, our targeted environment is a hospital. So especially our USC Keck hospital, this is a critical care hospital, so no primary care. So we have over 400 rooms where people are pretty unwell there, come for care, and the cancer hospital. And so we were able to instrument most of the rooms. They're divided into units. But the important thing is the patient is at the center of the whole care system. And all the people surrounding that are the people that we were studying to see how they go day to day. It was a 10-week study. Continuously they wore, every day they come, they wore garment-based, like a t-shirt or a sports bra-based sensors, which provided ECG, respiratory data, movement data, Fitbit, which is a low-grade one, audio badge, and phone-based activity, their EMR activity. So you kind of have a good mapping of what they do when they come to at work. In addition, we have all these sensors. These are my students. put stuff in every ICU, nursing station, med room, and so on. So this is just a summary of the sensors we collected about social, bio, environmental behavior trackers, and just a sort of pictures of some of the sensors we used. Most of them are COTS, right? We wanted to do it at scale because, and it was mediated with an app that we built on the phone, both iOS and. So the idea was we collected data from about 350 people over 10 weeks continuously. And so we did it in 2 waves. The first wave recruited about 200 plus people, and the second wave about 140 people. And it gave us a very good sort of data dump, which just got over like a few months ago. Just this morning, our phase 2 was approved, so it's good. I was pretty nervous about it. That's a lot of data. And just to give you an idea, this is like 100,000 hours of audio and localization data and ECG data, etc., etc. And we are trying to figure out how to map an individual in a dynamical way to look at routines and patterns. Here I'll share some sort of what is interesting in this context of HBI is that like how can we understand individuals' behavior in space and time, in built environments. A lot of it was, when we recruited these people, it was based on participatory design. People were talking about which location bothered them more. Med room, they would rather be in the patient room. The alarms and sounds bothered them. The cold and at like the night shift. Whereas a lot of these things came, so that informed what to collect for us. And here's a behaviogram of one person, right? We could pretty much with this data map what they do when they get up, how they sleep, what they do when they wake up, check their phone. They even checked our app, and when they completed their survey, what kind of data about heart rate and breathing rate and audio. So you get like a full map, multimodal time series. In fact, digging in a little deeper, so here's like when they are sleeping and they are commuting. This person actually commutes with a bike, and then they are here in their hospital for 12 hours. So we can look, how much they speak, where they speak. So in the patient room, they speak a lot. These are nurses, so they talk a lot to the patients. When they use the phone, how their heart rate varies, etc. So we can get a very good mapping of how people interact in space and time in the building. Here's locations in work, right? So we can say where they spend most of their time, and how to optimize for it. So these dots are basically sensor position localization. You can see this is a particular unit in our hospital, unit 4, 4th floor. And so you say day shift people are assigned here, night shift people are mostly spending time here, and where they spend more time, darker, more time. And in fact, it was very cute that they always complain about being in the med room, right? And so we can see increased sort of elevated breathing rate when they go to the trips to the med room. We can actually map it with our data. So these kinds of things that we can actually get a really good mapping. In fact, we can see how what kind of movement patterns and how their behavior mapping can be done. For example, we can discover motifs, routines of where they do, right? Here motifs are like, typically they go from nursing station to patient room back to the med room, or these other motifs can be discovered. And we can figure out what typical clusters emerge and, trying to see how to optimize and so these are kind of provides sort of building blocks for understanding sort of how humans and the environment in which they operate over time can be modeled. So just gave you some examples. What we are doing mostly is to use all our sort of various machine learning ideas to try to understand these very complicated time series multimodal data to see how we can optimize for sort of what interventions and what support can we provide. A lot of the motivations here came from not only getting the window into the human traits and states and behaviors, but how can we support that to optimize for reducing stress, improving productivity, sort of making them well so that they can do their jobs. What they want to do is care for other people to become well. And so this is an ongoing project, so very excited. So, but this pointed out a lot of challenges, right? Getting the right data is one of the most challenging thing in real work, environment. We went to someone else's environment and tried to rig up all these things to collect this data. And that was not easy to recruit 350 people whose main job is not to play with us, but to support people A lot of challenges in processing, variability, heterogeneity in this data, uncertainty in this data, and most importantly, a lot of people touched upon it, all the data provenance, integrity, ethics, and other questions that come into play. And so, in conclusion, sort of, we can study these human behavior varieties of perspectives, including this HBI sort of context, but it's both exciting technologically, but also societally, the kinds of possibilities that I'll stop. This work of a lot of collaborators with me and support from a lot of people. But thank you for listening.